Hey Amanda. So this is how I set up for helping you on the IXL. So first I'm going to explain what all of these theorems are, and then I took questions directly from each IXL so that you can see it applied. All right, so first let's break down all of these theorems. We have SSS, SAS, ASA, AAS, and HL. HL standing for hypotenuse leg. Now, the S's stand for the sides of the triangle and the A's stand for the angles of the triangle. So if you have SSS, that means that if you have two triangles and you have three congruent sides, or rather one of each side is congruent to one of each side of the other triangle, just like you can see from the markings, then these two triangles would be congruent. If it's SAS, it's exactly like what it says. It's side, angle, side. So you need to have two sides that are congruent and then the angle that is in between them. So it has to follow that order. So this is the side, this is the angle, and then this is the other side. And then you see side, angle, side. So these two would be congruent. For ASA, it's angle, side, angle. So again, it needs to be in that order. It needs to be consecutive, meaning one right after the other. So we have this angle here is congruent to this angle, the side, and then the other angle with the other angle. So these two triangles would be congruent. So like for example, if you have these two triangles, right? And you have this angle and this angle, then this side, and then this angle with this angle, this is not ASA. Even though you do have an angle, a side, and an angle, it is not consecutive. If it was ASA, it would have to have been this side with this side, and then this angle with this angle. So you have to keep that in mind. It has to be consecutive. For AAS, that's angle, side, angle, side, you have angle, angle, side. So just the exact same thing, but it has to be consecutive. Okay. And the last one here, which is the hypotenuse leg, this only applies to right triangles. So it has to have that little box, or it has to have told you that it's 90 degrees. And this is that as long as you have one leg congruent to another leg and the hypotenuse congruent to the other hypotenuse, then these two would be congruent. It could also have been this leg with this leg, and then, like that, and then the hypotenuse and hypotenuse. It does not matter which leg it is, but it has to be the hypotenuse as well. All right, so let's take a look at the first IXL, which is K1, SSS, and SAS. Now, these are questions I pulled directly from the IXL. So the first one here says, which two triangles are congruent by SAS? So side, angle, side. Now, if you look at the markings, right, you see that this one has 1 and 3, and this one has 1 and 2, and this one has 1 and 2. So it has to be these two. And you see side, angle, side, angle, side. So it's not this one. So when you write out your triangles, remember that it has to be the corresponding letters. So let's say if I start with D, right, the one that is next to the 2, I have to start with H on this side. So it'd be D, E, C. So I went from D to the angle to the other angle, and then it would be H to the angle, so H, J, I. So this would be D, E, C, and H, J, I. For this one, it says which ones are congruent using SSS. And again, you got to look very carefully at these markings, making sure that they are the same. Here you have 2, 3, and 4. Here you have 1, 3, and 4, and then 1, 3, and 4. So again, it can't be this one because this one has the 2, whereas this one has the 1 and the 1. So if, let's say, I start with D, which is between the 3 and the 4, I would have to start with Z. And then you go around just like you would with the other ones, making sure that everything is in order. So if I go to D, B, C, then I have to go from Z, X, Y. And that's with SSS. This one here, we have which two triangles are congruent by SAS. So again, paying attention to these markings, you see here that we do have two sides, but the angle is not in the middle. If it's SAS, the angle has to be in the middle. So automatically I can rule this out because this is not following SAS. Whereas these two, see, we have the side, the angle in the middle, and then side, side, angle, side. So it'd be these two triangles. And let's say if I were to start with Z here, I would go Z and then let's say XY. So I went from Z, which is the one that's attached to the 1, and then I went to the one with the angle. So here I would have to start with F. This is the one that's attached to the side with the 1, and I'd have to go to G and then E. So F, G, E. So that's it for Ixl K1. I went through all the questions and they're basically just the exact same thing over and over. So we're going to move on to K3, which is ASA and AAS. Again, it'll tell you which theorem to look for. This is AAS, so we need to have two angles and the side directly afterwards. And you can see here that we have my angles. They're all with the two arcs, so these are all okay. And then this one, which has the one arc and the one arc and the one arc, but this has the side here and here. And even though this would also be considered angle side, we have this one that has the two markings instead of the one, so we can't use this one. So let's say if I start with a B and I'm starting with the two arcs, and then I go to D, it would be B, D, C, and then I have to follow the same order for this one. So J, H, I. For both of these are ASA. So angle, side, angle. And again, paying very close attention to the markings. This has one arc, one line, and two arcs. This one matches, but this one has the two, so it's not this one. It has to be these two triangles that are congruent. So if I start, let's say with S, then I would do SRQ, let's say. Again, remember, it doesn't necessarily matter which direction you choose, whether you go this way or this way, as long as it matches the direction you use for the next triangle. So if I did SRQ, I have to go YWX. So one arc to two arcs to none, one arc to two arcs to none. So YWX. For this next one, ASA again. Again, I'm looking at my markings. This one has two, and this one has the one, so it's not this one. So let's say if I start with X and then I go to Y and W, then I would have to go H, G, I. Again, just use those markings to help you write the order for the letters, right? So I did the two arcs to none to one, so then I did the two arcs to none to one. And that kind of helps orient myself. Last one for this IXL, this is AAS. So again, angle, side. Looking at my markings, I see that this one is the one that has only one line for the side, so it can't be that one. So it's got to be these two here. So let's say I start with the two arcs to none to one. This would be W, V, U, and then over here it would have to be two to one, none to one, so B, D, C. So that's it for that IXL. Again, it's just more of the same thing. It's all markings. It doesn't get any harder than that. So let's look at this next one. So this is where you have all the theorems combined and you have to decide which theorem is going to apply. So when you look at some of your triangles, you may not have all of your markings. So it would be helpful if you can kind of visualize it. I only have two markings here, but there's an additional marking that I can make. These two angles are vertical angles. Remember, vertical angles is when you kind of have like an X figure and the angles that are across from each other are congruent. So here, this angle would be congruent to this angle. And if I look at the order of my my markings, I have an angle followed by another angle, followed by a side. So this is AAS. You could have also settled, like, let's say you started from here and you said this is SAA. This is obviously not one of my rules, but if you just reverse it, right? AA, like read it backwards, AAS, then it's that. Again, we don't really have all of our markings here, but for this one, you see how they share this side. If they share a side, then these two are obviously like the side that they share are congruent because it's the same thing. So that this side of this triangle and this side of this triangle are obviously the same. So you can mark it and then to kind of help you figure out what would be my rule. If I look here, if I start with this side, I have a side followed by an angle followed by a side. So this is SAS. For this one, same thing. We don't have the third marking, but we have these vertical angles. So this would be congruent to this. Now, if I look at my markings here, and if I were to write down, I have a side followed by a side followed by an angle, which you can see is not in my list. And if I read it backwards, okay, same thing. It's not on my list. So if you end up with SSA or ASS, I know what that spells. Okay, haha. All right. It's not congruent. We can't say it's congruent. So you would say these triangles cannot be proven to be congruent. Last one for this IXL because again, it's just more of the same thing and it doesn't really get much harder. So here we have these two triangles. Again, they share a side. So I can mark that side because it's obviously going to be congruent to itself in each of these triangles. So if you just look at one triangle, we have a side, we have an angle, and we have another side. So SA, oh, yes, wait, I said it completely backwards. We have an angle, we have a side, we have an angle. So ASA. So I chose for this particular IXL one of each type along with the cannot be proven to be congruent. So that way you would see how it works. Oh, except I just realized I didn't find an SSS. But basically, if let's say if you have, let's say these two triangles and it's marked like this. This is the easiest one to identify because as long as you have all three sides that are congruent to the other, then this would be SSS. Or let's say if you have, like in this same figure, like that, and you don't have that third marking, but we see that they share a side, this is also SSS. The last IXL is a little bit different, the hypotenuse leg theorem. Remember that for the hypotenuse leg theorem to apply, it has to be a right triangle, which all of them will be. And then that means that the leg, like the corresponding legs would be congruent and the hypotenuse would also be congruent. The hypotenuse in a right triangle is always that diagonal line, or if you can't tell which one is diagonal because of its orientation, it's always the one that is directly across from the 90 degrees. So this would be the hypotenuse. For all of the questions in this IXL, it's going to ask you to find for values that make the triangles congruent. So here, since this is my hypotenuse and this was my hypotenuse, then this would have to equal to this. So T would equal to 46. And then this leg would have to be congruent to this leg. So S would have to equal to 16. So those in the beginning are pretty easy because it's whatever the value is given will be your answer for the corresponding triangle. However, for as you move on in difficulty, and so here I did choose one from each level, so that way you see how it gets harder, you will have to set up an equation to be able to solve. So I find it helpful to just label my hypotenuse so I can orient myself. This 40, that's the one that's across from the 90 degrees, so this is the hypotenuse. And the 5x is also the hypotenuse. So that means that this has to equal to that. So 5x has to equal to 40. And to solve for x, which is what we need, we would divide the 5, and you get that x is equal to 8. Same thing for the leg. We have this little leg here, has to equal to this leg here. So you can set up your equation that 2y has to equal to 16. So I would divide the 2 to each side. So y has to equal to 8 as well. For this one, this is once it gets a little bit more difficult. We have this side and this side. Again, they have to equal to each other. So b plus 8 has to equal to 2b. And we use this equation to solve for b. So I can subtract the b from here to move it to the other side. And we get that 8 is equal to b. So done. Then we would do the same thing for the hypotenuse, which is obviously, again, directly across from the 90 degrees. 6a has to equal to a plus 35. And you use this equation now to solve for a. So I would subtract the a to both sides, and we get 5a is equal to 35, and then divide the 5. So a would have to equal to 7. The last type, and the one that you get at the highest level, you'll end up with something a little bit more complex. So I'll explain how to do that. We have here this hypotenuse, which is x plus 31, and this one, which is 40. And then you have these legs here where you have two variables. You have wx and wx. So the trick to these is to find the equation that has only one variable. So you can write them both at the same time, right? Like I could say x plus 31 has to equal to 40. And then 2x plus w plus 6 has to equal to the 2w plus x plus 1. So when you're trying to solve for both of these variables, start with the equation that has only one variable. So here I would subtract the 31, and you get that x is equal to 9. So that part is done. Now when you get to this equation, right, since we've already solved for x, what we can do is plug it in wherever we see the x. So this would be 2 times 9 plus w plus 6 is equal to 2w plus 9 plus 1. So I just replaced all the x's with what I solved. So that's what you're going to do. You're going to use the first equation that has only one variable to solve for that variable. And then in the second equation, wherever you see that variable, you plug in the number. So now we have 2 times 9, which is 18, plus w plus 6 is equal to 2w, 9 plus 1, which is 10. We can also combine the 18 plus 6. So 18 plus 6 is 24, is equal, plus w, is equal to 2w plus 10. And now we can solve for w. I'm going to subtract the w from here, which you could also have subtracted the 2w if you wanted to. It doesn't matter the order you choose. So 24 is equal to w plus 10, and then I would subtract the 10. So w would equal to 14. And those are all of your Ixls.